Hello, my name is Audrey Dilig, and today I'll be presenting on Yosemite National Park, more specifically the Yosemite Valley region. Let's get started. During this presentation, we'll be going over the types of rocks found at the site, the subtypes of those rocks, the ages of those rocks, the minerals found at the site based on those rocks, notable geologic features, the ages of those geologic features, site topography, a geologic map overview, and a brief geologic history. Now let's take a look at the rock types and subtypes found at the site. Starting off with igneous rocks, the National Park Service describes how Yosemite is heavily dominated by large granitic formations. Since granite is formed from magma that cools and solidifies within the crust of the planet, it is considered intrusive and plutonic. However, you could also find the extrusive equivalent to granite on site, which is rhyolite. There's also obsidian and basalt on site. These are volcanic and extrusive. Moving on to metamorphic rocks, although this type is considered sparse, making up only 5% of the area, the NPS Geology section lists that you could still find both non-foliated and foliated rocks on site. This includes marble, quartzite, and slate. Last but not least, we have sedimentary rocks. Although the majority of the type was metamorphosed, the area used to be covered in clastic rocks such as limestone, sandstone, and shale. Now let's take a look at when exactly these rocks were formed. The massive bodies of plutonic rocks in Yosemite were formed from constant intrusions of magma into older host rocks beneath the surface of the earth. UC Merced's research on Yosemite shows these intrusions were expected to take place at a time period around 130 million years ago. The Journal of Structural Geology talks about the joint formation of granitic rocks in Yosemite. The ages of the other types of igneous rocks found on site range from 80 to even 210 million years old. As for the metamorphic rocks found on site, the age ranges from 100 to 118 million years old, depending on the area. NPS talks about how their eruption from volcanoes actually occurred around the same time that some of the smaller plutonic rock suites were formed. Lastly, we have sedimentary rocks. These rocks are expected to be around 130 million years old. Based on these types of rocks, the NPS Geology section states the minerals found on site include quartz diorite, potassium, feldspar, plagioclase feldspar, biotite, and hornblende. Our first notable geologic feature would be glaciers. These glacier formations were formed when snow and ice gathered at the high elevation of the mountains. To put this into perspective, the USDA shows in their geologic and climatic history of California that Yosemite can range up to 13,000 feet in elevation, and the lowest recorded temperature is around 21.1 degrees Celsius. Next, we have the beautiful streams and rivers. Just as the weather has reached lows, it has also reached heights of up to 46.1 degrees Celsius. After the snow accumulated and the weather eventually reached these heights, the snow melted and formed these natural reservoirs. Next, we have the famous canyons of Yosemite. Yosemite is a part of the Sierra Nevada. The NPS Geodiversity Atlas shows narrow canyons were formed when the Sierra Nevada was uplifted, increasing the steepness of streams and riverbeds. Lastly, we have the Sierra Nevada Fault Zone, which Yosemite lies on. The USGS Quaternary Fault and Fold Database of the United States describes how this fault is comprised of several normal faults. The California Academy of Sciences explained how a normal fault is formed when rocks above an inclined fracture plane move downward, sliding along the rock on the opposite side of the fracture. Going from youngest to oldest, glaciers were formed around 1 million years ago, streams, rivers, and canyons were around 10 million years ago, and the Sierra Nevada Fault Zone was formed 200 million years ago. I will go into the names of these features through the geologic map. Now let's delve into Yosemite's geologic map. New Mexico Tech describes geologic maps as the representation of the distribution of different types of rock and superficial deposits, as well as locations of geologic structures such as faults and folds. This USGS map of Yosemite Valley has a scale of 1 to 24,000, a contour interval of 50 feet, and an index contour interval of 5. In this section, take a look at the correlation and description of map units. As you can see on the left side of the map, these essential elements come from the pre-Cretaceous, Cretaceous, and Quaternary time periods. And on the right-hand side, you can see that the map is color-coded to showcase the different types of elements such as granite, granodiorite, and the metamorphic rocks. taking a closer look into the middle of the map, you can see titles such as the rock slides or the leaning tower that showcase where mountains lie. The map also showcases other geologic features such as the Bridalveil Meadow, the El Capitan Meadow, and the Merced River. The map even provides non-geologic features such as the El Capitan Bridge. On the other hand, the topographic map studies the forms and features of land surfaces. These maps reveal the shape of a landscape, showcasing the elevations that indicate the height above sea level through contour lines. This map has a scale of 1 to 24,000, a contour interval of 40 feet, and an index contour interval of 5. These contour lines allow us to visualize the high elevations of mountains and peaks on a second-dimensional scale. Other than mountains and peaks, this type of map also showcases other principal points such as bridges and waterfalls. You could find a detailed description in the top left-hand corner. This map's highest point of elevation is the Cloud's Rest at over 9,000 feet. Lastly, let's get into my interpretation of the area's geologic history. Yosemite National Park could be found in the Sierra Nevada. The Sierra Nevada was formed more than 200 million years ago. Prior to its formation, the Sierra Nevada was covered by the Pacific Ocean. At the time of the Permian Epoch era, sediments were elevated and folded, creating ranges of mountains. Originally, they were composed of shale, sandstone, and limestone. They eventually metamorphosized into marble, quartzite, and slate. For millions of years to follow, new layers of sand, mud, and slate accompanied by volcanic rocks folded and formed a new range of mountains. A majority of the original sedimentary rock dissipated, and massive chunks of volcanic igneous rocks dominate the geologic area, making Yosemite National Park. As we wrap up, here are the references I used throughout my presentation. I hope you had fun exploring with me. Until next time, thank you.